FE peer review asked, where is the 45-foot contour line? Well, the 45-foot contour line is the lowest of these three purple lines. It's the one that's marked 45 feet. You'll have a nice day. Actually, slightly more information than that. Way over here on the left side, not very visible at all, extreme left side, there's a little purple crosshair. That is my 0, 0. That is where I pointed the camera in this simulation of the view. That is well to the left of the view that I'm simulating to make things easy for me while I'm plotting it. It gives me fewer things to screw up if all the x-coordinates are positive numbers. You could put it over to the right. Bear in mind that this thing is only 4,000 pixels or so of plot. 4,000 pixels, considering I'm using 5 figures, 5 decimal places here, is 0.04. And the tangent of 0.04 is 2.29. So we're only looking at 2.3 degrees of image from that purple thing across to wherever 4,000 pixels is. Plotted on this, fairly obviously a 200-foot contour line, which comes across here. It has a couple of creases in it. You can see there's a little tiny step in the top row there. That's a crease. There's one just here. There's one there. And there's a much bigger one here where it goes out to the right, doubles back to the left, and then comes across to that spot. See, that big crease is repeated up here, and there's also a crease just there in the 400-foot. And then you still have a significant zigzag up here in 600 feet, and a whole load of them in the 800-foot contour, and a couple in the 1,000-foot contour. This does go up higher than 1,000 feet. It goes up most of 2,000 feet. But we're interested in this part because this is the part that was actually on the screen when he asked, so I haven't plotted all of that. In the background is Red Mountain, which goes above 2,000 feet. I haven't plotted that either because, again, we were only looking at this part. Down here we have the 0-foot contour line, the coast, drawing a nice beach-like orange, which also has this fold in it. There is a sort of an inlet or a bay or something there. From La Conchita across past Muscle Shoals. And yeah, I got carried away, went way off the right side. We are now out past 4.6 degrees. In blue, in 2 shades of blue, there are multiple lines across here, going out to way out there, from points all the way back here. Just there, these are points along a measured distance line from the staged observation point at University of California, Santa Barbara car park on whatever headland it is, across the headland in interest. So this is the left side of that is that line that skims the headland. You can see the purple frame with the 45, 90 and 135-foot contour lines at the headland actually extends inland to where the houses are and some way out to sea. And the yellow thing, which is labelled 45 feet, 3 kilometres to 14 kilometres, well, that's 45 feet above sea level at 3, 4, 5 out to the right, 6 and 7 nearly lined up, 8 back towards the middle, 9 to the right, 10 to the left, 11 to the right, 12 and 13 way over on left, and 14 at the bottom in the distance. Kilometres. Going from quite close to give you some idea of eye level, although it's not exactly lined up. It's still, even at 3 kilometres, it's slightly below eye level. Out to 14k, which is something like the distance to the headland. These blue lines, I think, are 13 to 15.5. 13, 13.5, 14.5, 15, and 15.5 kilometres, I think, because that's where I worked out that the horizon would be. So those were the obvious distances to plot. This is just the geometric view with actual curvature and no refraction. Obviously it's simplified, the skyline won't be quite as angular as that. But of course I didn't just plot geometric view, I also plotted the flat view. Keep having to zoom in on these because they are very big images. Start over on the left, we have that same purple mark. We have the same 200, 400, 600, 800 or 1000 foot contour lines, and they look kind of similar and they have the same folds in them. And we have them joined down the right side to give you the end of the ridge the same way. Below the 200 foot contour line we have the coastline, this orange line here. Also extends far off to the right. Above it we have the purple frame, which is 45, 90 and 135 feet among the houses on the headland and out at sea. And lined up across the bottom of that is the same set of yellow points. If you assume sea level is flat and do these calculations, for an observer at 45 feet, a whole bunch of points at 45 feet and a line at 45 feet at the headland all line up. Somewhere behind them would be the 45 foot contour line on the distant mountains. Notice the blue here is slightly different. This is because if you assume sea level is flat, of course, you don't get a horizon. It would just stretch off to infinite distance. And a very big difference, this orange coastline is above the horizon. What about refracted globe? Well, refracted globe is next. And on this, I have actually left off the slope on the right. That's going to be significant later. Again, there's our aim point. Here we have 1,000, 800, 600, 400, 200 and 0 foot contours in green, 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 green and orange. With all those same folds in them, we have the same purple frame and we have, again, sea level at those distances. You'll notice that the sea level line is almost a single line. It's just a little fatter in a few places. It took a whole lot of drawing for a line that's only 1 pixel thick, because that is, again, many different distances. Orange coastline is back to being below sea level. 200 foot coastline is 200 foot contour line is above sea level. And the sharp-eyed will notice that the purple frame is leaning slightly down to the right. This is an artifact of the way these calculations are done. I assume the camera tripod is lined up with the center of the Earth rather than with gravity, and then the camera is swinging around and tilting relative to that line. And because we're looking slightly south of east, you have this slight tilt effect. You can see that the sea level horizon is sloping up to the right. That is Earth's ellipticity showing up in a photograph there, because your camera was aligned to radial rather than to gravity. What happens if we compare all of these together? What do you think we'll get? I think we'll get a mess. And there we have a mess. Let's zoom in again. Oh, hello. This is not a mess. Sorry, this is the next frame. My bad. This is the refracted plot with the sloping line drawn in, and also with lines from the creases in the foreground up gullies. So you can see where there is an edge between gullies there, and the near side of the bigger gully, and there is the near side of the next gully there, and a smaller one down here. Then we get to see a mess. That's a mess. I've also cropped it down to a more sensible size, so there's slightly less zooming in required. This is certifiably a mess. The labelled ones are the geometric. The ones that... Well, it's kind of hard to say what's going on, isn't it? You know the labels are on the geometric, and obviously the coastline slightly above the label coastline is refracted, and the one that's way up here is flat, but that's just a mess. So let's simplify things. Let's have the geometric and refracted plots with the contour lines lined up. You can see over here on the right the 600-foot contour line is lined up, and so are parts of the 800 and the 1000, and a few spots on the 400, and even a couple of spots on 200, like the very right end of it. Oh, lined up. So we have the mountain. Is 2,000 feet a mountain? Not really. Hill. Beyond La Conchita. This is the hill behind La Conchita. La Conchita is somewhere down here at the bottom of the image. Lined up for the two. And purple hasn't really worked out. We've got far too many purple lines, and it looks like it's gone horribly wrong. And the coastlines are pretty much superimposed. So we have pretty much the same shape of landscape here. Very slight difference. One pixel in most places. 2 pixels in a few places. Not much different. But there is one thing that is very different, which is down here. Well, there are two things actually. There's that yellow line of sight where you can see how the label has been crossed out by this lower line. That's the refracted line crossing out the label on the geometric. Your refracted line of sight at 45 feet actually works out lower relative to that distant hill. This is lower, not relative to the centre of the photograph or relative to eye level, lower relative to the distant mountain in refracted than on geometric, because of course the mountain has been refracted. It's farther away, and refraction lifts it more than it lifts these much closer points. The other thing that is very different is the sea level. Geometric sea level is the fat blue line, the upper of the two, where you can see the two different colours in which it was drawn very clearly, and the refracted sea level is lower relative to the distant mountain because it's closer and has been lifted less by refraction. So there's your difference between geometric and refraction. Sea level appears lower relative to the distant mountain in the refracted view. For a different comparison, we can line up the purple frame at the headland, and because of the that whole radial and scaling and vertical thing, the two purple frames are actually tipped opposite ways in the view. So I had to choose which part to line up. The part I chose to line up was here, where the 45 and 90 form single lines at the left end of the horizons at sea, because that's, where the headland is. And the plotted sea level positions are massively different relative to that, and the plotted contour lines on the mountains are massively different relative to that. And it kind of makes it look as if I screwed up, doesn't it? It's just bizarrely massively different. I may have failed to get the positive and negative y coordinates right there. Fortunately, I have other things plotted that I can use to line it up, such as the horizon. I mentioned that the horizon was different due to refraction. Well, here they are lined up. If you go across the top of this fat bluish thing, the highest pixel keeps switching back and forth between whether it's part of the refracted horizon or part of the geometric horizon. I've lined them up that nicely. And here you can see the purple relative to the horizon looks kind of bizarre. Much lower with refraction than geometric. Still possible I got that wrong. But again, we have another way of looking at it. We have this distant point, 14 kilometers in the at 45 feet. Well, I think the 13 is a better match. The 13 kilometer point in that is the same. So maybe that's the distance to the horizon. And then one or the other is higher, closer and farther than that. In the background you can see I've used the refracted plot that doesn't have the slope on it, so you can tell which is which. These contour lines that just end in space without being linked by diagonals, those are the refracted positions of contour lines. The ones that are linked are the geometric. And refracted is consistently just that little bit higher, in this case relative to the visible horizon at sea, than geometric, which is exactly what you'd expect from refraction, bending our line of sight down and making things appear higher. But that's just geometric versus refracted, and we already knew that. One more thing I can line up. The near end of eye level. Rather than matching them at 13 kilometers, let's match them at 3. And here you get the refracted eye level, refracted 45-foot line rather than eye level, is the upper of the two yellow lines because it has been refracted up a little bit, just that much, just a tiny amount. Bear in mind that each pixel here is, open calculator app, 0.00001 inverse 10, 573 micro degrees per pixel. Yeah. It's a pretty small difference, but it's there. The mountain is farther away, and therefore the refracted mountain is higher. Is more higher. The mountain is refracted up more than eye level. Than the 45-foot line here, which is much closer. Pretty good illustration from 3 kilometers being the same, well, almost the same spot. I appear to have missed by 1 pixel. You've got 4, 5, 6, and so on, increasing separation, and then more and more separation as you get farther and farther away up to the 1,000-foot contour line here. That's geometric versus flat. Sorry, geometric versus refracted. Ugh, I can brain. That was geometric versus refracted. This is geometric versus flat. And again, I've lined up the contours. I have lined up the right-hand end, in this case, right-hand ends of the 200 and 400 foot contour. You'll notice there is this very slight difference. Over on the left it's fairly obvious because I stopped the geometric short and labelled them and extended the flat plot far left and didn't label it. It becomes obvious that the flat plot is the upper line at 1,000 feet, the lower line at 600 and 400 feet. Crazy, huh? But over here on the right we get pretty similar shapes. It's just a little bit stretched vertically. Not much. And we get the coastlines in very similar places. But where it says coastline, there is a yellow line superimposed on the purple. That's your 45-foot eye level, assuming sea level is flat. And way up above it is the yellow zigzag, which is 45 feet above sea level with geometric curvature and no refraction. And right at the bottom of the screen, the very bottom edge of this image, you can see just a couple of blue lines. Yeah, those are sea surface at the same distance as this fat blue horizon from the geometric plot. Well below, well, they're both well below the yellow, but it's well below its orange line, where on the geometric, the sea is well above the coastlines. That's a difference. Same thing, but line up geometric versus flat, but line up the headland. And apparently I lined up the left side of the frame at the buildings rather than the coastline. This time, that's fine. If you line up the headland, which is in the foreground, you get geometric coastline is way down at the bottom there. The flat plot coastline is much higher. 45 feet above the sea at... It's a black bar across here because of me correcting a mistake and then in a really crude way and then not fixing that problem, but 45 feet above the sea at 14, 13, 12, 13.7 kilometers, maybe? geometric lines up with the coastline in the distance flat. Doesn't seem right. Yeah, flat plot coastline is way higher. The flat plot mountain, hill, whatever you want to call it, way beyond the headland, is way higher. See up here and over on the left, you have the 1,000 foot contour of the geometric plot, and above that you have the 800 foot contour of the flat plot. So that is quite a difference. And looking at the sea levels, you have all these parallel lines showing sea surface, assuming sea level is flat, are well below this, basically a single orange line of the distant coastline, and lined up with the 200 foot, single pixel orange line of the distant coastline in the flat plot, and they line up with the 200 foot contour line in the geometric plot. And then below them is the horizon. It's not that far below them, but it is definitely below them on the geometric plot, and well below that is the coastline on the geometric plot. Next, we can also compare geometric versus flat using those sea surface lines. But obviously you have to pick which sea surface line to use, and due to the camera tilt issue, which part of it. So there is a fat blue line diagonally through the middle of those skinny blue lines, which is roughly lining up the sea at the distance to the headland, which gives us the same thing. Geometric plot coastline is well below sea level, flat plot coastline is well above sea level, and the headland geometric is higher than flat plot, and in the distance on the hills, that distant range of hills behind La Conchita, flat is higher than geometric. One more comparison of geometric versus flat. Eye level. 45 feet above sea level at 3 kilometers distance on the geometric plot is the top of this little short bit of diagonal yellow line, and 45 feet above sea level at any distance on the flat plot is the long horizontal yellow line, and they are lined up. And you can see that with the geometric plot, that 45 foot contour zigzags off into the distance because it's very hard to click the exact same place each time, and this is massive magnification. And when we're looking at, what did I say it was? 0.53 degrees. That's a really small field of view, and this is a small, that's horizontal. The vertical part of this is only about a third of that, and we're zoomed in. This is massive magnification. You can see that the farther away this 45 foot level gets, the farther below eye level it gets, which is exactly what you'd expect with curvature. And there at 14 kilometers, it has gone below the flat plot sea level, but it's still well above the geometric plot sea level. You can see two orange lines. The upper orange line is the flat plot coast, and the bottom orange line is the geometric plot coast. Huge difference in where the distant hills appear. And those two green wedges, let me zoom out a little, get more of them on the screen. As you can see by the labels, the upper green wedge, which has gone right out off the top and outside the image, is the flat plot, and the lower one is the geometric. So we have for a 600 foot contour line in the flat plot, pretty much lined up with the 1,000 foot contour line of the geometric plot. Quite a difference. Now we have refracted versus flat, doing the exact same thing. Line up the contour lines at 200 and 400 feet on the right side there, and you get very similar shapes, just a slightly different view. But your headland heights are different. Which one's which? Well, the one that goes straight across is flat, the one with the angle is refracted geometric, refracted globe. And your sea level heights are very different. You have two orange lines down here which look pretty similar. The upper one with the obvious zigzag is the refracted globe, and the lower one, which appears just to be a flat line, is the flat. This sloping single line in blue, the upper line, which is almost a single pixel line and has a slight slope to it because the camera is radial to the earth, not vertical, is your refracted globe, sea level horizon, and these lines way down here below it, below the coastline, meaning the coastline south of La Conchita would be visible, are bits of sea level at the same distance in the flat plot. Refracted versus flat headland. We have lined up the purple frames. I have lined up the purple frames, and again I have lined them up. Well, I've lined up actually the 135 foot at the left end of the sea level plots. So if you use the headland to anchor your photograph, the height of the building and the coast at the coast in front of the building at the headland to anchor your photograph, this is the comparison you get, and you can see again, refracted globe is the green lines that aren't linked at their ends by a diagonal. So if you line up the headland, the distant hills appear higher in the on a globe with refraction than they would above a flat plane. And the sea, at the approximately the distance of the headland, appears much higher. It is still this upper sloping thin blue line, and the flat plot sea is still the low set of parallel blue lines. We also still have the refracted globe coast on that distant set of hills with the pronounced zigzag, and it's from this distance it's viewed from underneath. So this point here is actually closer on the right. The sharp point is closer than the mainland bit behind it. On the left, in the centre of the image, the sharp point there is the inlet behind the bit of land, or the bay behind the bit of land that is plotted above it. Below that you have that single line of what the coast would look like seen above a flat plane, and it really would be seen because below that you have the blue lines of where the sea would be if sea level was flat. Refracted versus flat horizon. Again, the question of how you line up an actual horizon as seen on a globe with refraction, which is the sloping bold line, with sea level stretching off to infinity if sea level is flat. And you can't really, but you can line it up with the most distant of those lines, or with the one of those lines that is something like at the horizon, which I think I've lined it up with the 13.5 kilometre, the 15 kilometre, because the yellow line goes out at 14, those are 13 to 15.5, I've lined it up with the 15 kilometre line, ish, at the left side. So we have the sea level with the headland in approximately the same place. You can see that the zigzag orange plot of the distant coast is well below that, and the straight line orange plot of the the zigzag orange plot of the distant coast on a refracted globe is well below that horizon. The single orange line of the distant coast on a flat plane is above the water at that distance and would be visible. The 200-foot contour line on a refracted globe is pretty much in the same place, the right end of it, where it folds back round and goes out of sight, is pretty much where the coast would be if the Earth was flat. Above that you can see a purple line with a yellow section, that is the 45 foot at any distance above a flat plane. That's your eye level in the flat plot. And you can see it lines up with about 13.5 feet in the refracted globe plot, the yellow zigzag. Did I say 13.5 feet? 13.5 kilometres away. 45 feet above the sea would be as far above the horizon as 45 feet above the sea is above the sea at the distance of that horizon. Obviously. And the bit about the green contour lines being much lower with curvature, even with refraction, than they are without, is borne out up here where you see, so I guess the 400-foot contour line is exactly lined up with the 200 there. And this is a 6, and that's an 8. Yeah, centre of the screen there, you have the 800-foot contour line of the refracted globe plot below the 600-foot contour line of the flat plot. And here we have 1,000 feet refracted globe and 800 feet flat. And there is, what are you going to call that, a fifth of that separation, about 40 feet. So 1,000 feet on a globe with refraction appears where about 760 feet would appear with no curvature and no refraction. Finally, line up eye level. The yellow, again, 3 kilometers. Well, any distance 45 feet above sea level on flat and 3 kilometers 45 feet above sea level refracted globe are lined up. The yellow zigzag, that's the yellow horizontal. The yellow zigzag coming down from it is where 45 feet above sea level drops down due to curvature. You can see it gets down as far as the parallel blue lines, which are where the sea level at the distance at 13 to 15.5 kilometers would appear if Earth was flat, and well past this single orange line that is the coastline south of La Conchita if Earth was flat. And then below it you have the 200-foot contour on a globe with some refraction, and below that you have the horizon on a globe with some refraction, and then below that this orange line at the bottom, which does zigzag, is the coastline south of La Conchita on a globe with a little bit of refraction. Zoom back out, you can see the right ends of a bunch of green lines, 2, 4, 6, 800 and 1,000 feet, without being linked up by diagonals from the refracted globe plot, and the ones that are linked by Okay then. I appear to have run out of actual words and I'm now just producing random syllables. Let me try that again. And the ones that are linked by diagonals are from the flat Earth plot, 2, 4, 6 and 800 feet and 1,000 feet right at the top. And here you can see that with 45 feet above sea level at 3 kilometers distance lined up, that 1,000 foot contour on the globe with a little bit of refraction is something more like 600 and, I'm going to call that 60 feet-ish on the flat plot, which is quite a big difference. And the two purple frames don't even overlap. The one at the bottom has the slope and therefore is from the refracted globe plot. If you line up 45 feet above sea level at 3 kilometers, the headland on the flat plot is, well, 45 feet on the headland on the flat plot is above 135 feet on the headland on the refracted globe plot. There is that much difference. So if you want to know where the 45-foot contour line on that headland is, pick one of these, the geometric, or the flat, or the refracted, with slopes. Line up the green lines with the distant hills, and the bottom purple line is your 45-foot contour. I hope this helps.